Hello and welcome to Notes 2020. Thank you for joining us today. I am Prithvi of Data Umbrella. Data Umbrella is an inclusive community for underrepresented persons in data science, machine learning, and artificial intelligence. We organize around 2 webinars a month, as well as open source sprints, and have a great library of videos on YouTube, so check out our YouTube channel. We are on all social media platforms under Data Umbrella. Next, I'd like to introduce you to our speaker, Villedieu, a co-founder of Linkurious, who will be presenting on stopping money laundering with graph analytics.
Hello everyone, today I'm going to discuss how to use graph analytics to stop money laundering. My name is Villedieu and I'm a co-founder of Linkurious. At Linkurious, we provide Linkurious Enterprise, a graph-based investigation platform that helps analysts make sense of complex collected data. It's used in a wide range of scenarios, including cybersecurity and data governance, but most of our clients are fighting financial crime. Today, I will share some tips based on experience working with them. We'll start by a quick primer on what is anti-money laundering, or AML, and why it's so important. Then we'll explore why graph analytics is great for AML. And then the bulk of the presentation will revolve around concrete examples of using graph analytics to fight money laundering schemes. So I've mentioned a few times money laundering and anti-money laundering. I guess a good place to start is to explain what is anti-money laundering. So the outcome or byproduct of a lot of criminal activities is illegal money. And criminals then look for ways to introduce this money into the financial system. This first step is called placement. The criminals then use different tactics to hide the illegal origins of the funds, and that's called layering. This would be the second step. Finally, they tend to use the money to buy nice cars or other things. That's the final step of the money laundering process, and that's called integration. Anti-money laundering consists in stopping that money laundering cycle at any stage of the process. And it's really critical to remove the incentives and the financial incentives that are associated with crime, such as corruption, drug trafficking, human trafficking, and so on. So that's why when we talk about anti-money laundering, it really is a very important topic. A few weeks ago, if you've been following the news, you may have seen that the ICIJ, the International Consortium of Investigative Journalists, and its partners published stories around the FinCEN files throughout the world. So this investigation, the FinCEN files, was successfully conducted with the help of both Linkurious Enterprise and Neo4j. The FinCEN files investigation are based on suspicious activity reports. So this is a type of document filed by financial institutions when they fear that a client, a transaction they are processing is illegal. And for this investigation, a few hundreds of journalists spent more than a year to analyze less than 1% of the files processed by FinCEN, the organization which is responsible for analyzing the suspicious activity reports, or SARS, in the US. So Linkurious Enterprise and Neo4j helped the reporters uncover evidence of how corrupt politicians or crooks are using the financial system to move money around. The FinCEN files investigation really shows how difficult it is to analyze financial data to fight anti-money laundering. A lot of time, that type of analysis comes down to understanding the connections. For example, we, as a bank, may have a client like the person on the right, and I want to know if that client is indirectly connected across a bank account, money transfers, and so on to someone who has been accused of corruption. And if I'm not able to follow the connections, I won't be able to identify that my client may actually be helping a corrupt official launder money. The graph approach is perfect for this sort of problem. By thinking about data as a set of nodes and relationships, we can uncover hidden relationships in complex data sets. And with GraphDBs such as Neo4j, it becomes possible for a bank to build a very holistic picture of its clients. So why is such a holistic picture, or 360-degree view, so important? With traditional approaches, AML investigations are slow or error-prone. analysts need to chase information which is scattered across different tools and different types. So it's not super effective. With Linkers Enterprise Intuitive UI, the investigations are accelerated, and you can make sure that you act with the full confidence of a complete picture, no matter how complex the situation is. Another issue is that traditional tools are focused for performance reasons on queries with limited numbers of connections, such as how many transactions has the client done in the last 30 days. By leveraging Neo4j and Graph Analytics, Linkers Enterprise doesn't have this type of constraint. So with its dashboard powered by Graph Analytics, Linkers Enterprise can uncover schemes that traditional approaches would simply fail to detect. So we have built Linkers Enterprise to help graph experts quickly turn the power of Neo4j into business impact. Linkers Enterprise is an investigation platform compatible with the Neo4j graph database, and it helps investigation teams detect and investigate insights hidden in graph data. I will be using Linkers Enterprise in the next demo section. And with Linkers Enterprise, we will easily be able to turn our AML graph queries into relevant alerts or action buttons. But first, a quick word about that demo. So we have built a fake data set, and that fake data set consists in about 3 million nodes and some 40 million relationships. Within OnGraph, we have clients, we have companies, we have addresses, emails, phone numbers, bank accounts, IP addresses, ATMs, and transactions. And you can see with the schema on the right, all these different things are all interconnected. So in the demo, I will be showing a few concrete examples of applying Graph Analytics to answer common AML questions. We will, for example, identify suspicious transaction structures, identify fake identities, or track down beneficiary owners of a fictitious company. So these are 3 examples, but it's just some of the ways Graph Analytics can help tackle the challenges of anti-money laundering. Okay, so let's start the demo part of our presentation, and we are going to start with a few examples that where we have a starting point, such as a suspicious client or a suspicious transaction, and we will be using Graph Analytics to analyze the context around our starting point to better understand the situation and then make smart decisions. So here we have our first example. So this first query revolved around exploring the neighborhood of a suspicious individual. We have heard about that suspicious client, and we want to get a feel for who the client has been doing business with recently. Specifically, we want to know who this person has received money from in the last 30 days. Now let's look at the code for query. So it starts with a match. We are identifying a bank account. Then we have a where clause. We are focusing on a specific bank account with a specific ID. And then we get to work with another match clause where we look into the as transfer relationship and the as bank relationships up to 3 levels down. And we want to identify the persons who are connected with our starting node via these type of relationships. Then we do some filtering by mostly focusing on the time difference. Checking that the time of the transactions are within the last 30 days. And then when we have finished, we actually return the result as a path. So fairly easy graph query, as we can see. We can analyze that in Neo4j. So I'm going to show you an example of this. So this is the Neo4j browser that we all know and love. As a developer, I can type my query. I can click here on run, and I'm going to be able to see a result in a few seconds. So we can see the results. So fairly easy process if I'm a developer and if I know Cypher and have access to the admin part of Neo4j. So it's not necessarily something that is true for AML analysts and investigators in banks. and that's really where linkers enterprise comes in. Now let's try to replicate the same type of analysis, except this time we are going to do that in linkers enterprise, and we'll see how easy it is to do that. So we are going to start with a starting point. It's that bank account, that suspicious bank account that we uncovered. We have a bunch of information about the bank account on the left panel. Okay, I can inspect that. But more interestingly, here we are going to see how to leverage what we call query templates at Linkerius, and we'll see how we can very easily use a graph query without having to know the first thing about graph or Cypher. So I'm clicking here on run query. I have a transactions in last 30 days query template. So I'm going to go ahead and click on that. Clicking on run now. I wait a couple of seconds, and the screen is populated with actually the exact same result as the results that we were looking at in the Neo4j browser. The difference is that we didn't have to see any Cypher code throughout the process, and that the whole thing is very accessible to end users and people with no technical skills whatsoever. So that's the end result. We'll see in a couple of seconds how we can make sense of that with the Linkerius Enterprise UI. But first, I want to talk a little bit about what goes on behind the scenes with that query template. So I'm going to open up the query template interface in Linkerius Enterprise. I'm going to look at the query template that we just used together, transactions in the last 30 days. I'm going to click on edit, and we can actually see the code. So it's, once again, it's the exact same code that was in the slide or in the Neo4j browser. There's a small caveat here, which is that there's a parameter, I guess, that's not specified. Here, instead of having a fixed ID, we are basically saying that the starting point, the node will be provided at runtime by the user. So it's, think of that as a variable query where the end user is providing some input. So this is one example of a query template, and that type of query template helps translate your graph queries that are super powerful into something that can be leveraged in the context of investigations or analysis by end users without having to know the first thing about Cypher and graph. Query templates are actually quite flexible. You can go beyond passing just a single node. You can pass multiple nodes. You can pass parameters via forms. It's fairly evolved, and it's a really powerful tool for developers and data scientists that want to enhance provide superpowers, graph superpowers to the analysts they are working with. Going back now to the Linkerius Enterprise UI. So what we have seen is how to leverage graph query to speed up the investigation process. But and Linkerius Enterprise helps do that, but it doesn't stop there. Now I have a result which is fairly complex with a bunch of nodes and relationships, and the Linkerius Enterprise UI can help me make sense of that complex graph. So first, I can see that some bank accounts here have multiple relationships. So there's been multiple transactions between that bank account that we were interested in the first place and this bank account here. So we can, for example, group the relationships in order to streamline the graph. So that's one way to unclutter a little bit your visualization and be more focused and avoid the type of error situation that we had in the Neo4j browser. But you can go beyond that. Let's say that across all of these different bank accounts, I want to locate the ones that sent the most money. I can click on bank account. I can see the different properties associated with the bank accounts. And for example, I can focus on the total amount sent. I'm going to go ahead and open a new panel associated with that property, and I can see the distribution of total amount sent properties. So for example, we see that we have 52 bank accounts that sent close to 100K, And at the other end of the spectrum, we have, for example, 2 bank accounts that sent 200K. Maybe I want to focus on once again the bank accounts with the most money sent. So I'm going to filter out everything left of that slider. We zoom out and we see that there's 1, 2, 3, and 4 bank accounts that are a little bit outliers in the sense that the total amount sent property is much higher than elsewhere. So that's one of the ways Linkers Enterprise helps you make sense of complex graphs. Let's go back to the dashboard. Let's go back to the presentation now. And we are going to look into yet another example. So for this example, it's important to understand that to comply with regulations, financial institutions need to identify for each of the companies they have as clients who are the persons who control them. So this is called the ultimate beneficiary owners, or UBOs. And we have a query on the right that helps us accomplish just that task. So let's look into the query once again. So it all starts with a match clause, then with a where. Basically, we are selecting a specific company here, and then we get to work with a match clause where we are looking at everything this company is connected to via each shareholder of relationship up to 10 level down. And then we have a where clause where we do some filtering. Specifically, we want to focus on the shareholder relationship where the ownership is above 20%. So basically, if a company owns less than 20% of another one, we're simply not going to consider that it controls that company, and we will not consider it as a UBO. So it's just a threshold here. That query help us identify the ultimate beneficiary owners in a very efficient manner. Once again, can be it can be run in the Neo4j browser. You can see the query. I can click on the play button, and I'm going to be able to see the result. And I can do the same type of things in Linkers Enterprise. I'm typing the name of the company this time. Don't have to type any graph query. I'm clicking on the result. I can inspect that result, and if I want, I can click on Run Query, click on Find UBOs, click on Run, and voila, we have the graph of all the companies associated with human kinetics. We can inspect that graph. So we have human kinetics here. We have Freedom Map here, another company. We can look into the relationship between the two of them, and we see that it's each of relationship, and the ownership percentage is 56%. Okay. At some point, we have uncovered the UBOs associated with human kinetics. If we want, we can actually save that result. We can also, share it with colleagues, or we can export it to a spreadsheet or a picture. So it's very easy to communicate the results of the investigation that we just conducted together. We can also look into the code for the query template. So it's available here. I'm going to go ahead and click on Edit, and it's pretty much the same code as the one that we saw in Neo4j or in the slide deck, except once again, there's a bit of a parameter here, which is provided by the end user when he actually clicks on the query template. Okay. So that's it for another example. Going back to the dashboard. Now I'm going back to the presentation. So far, we have seen how the graph approach can help understand the context around entities that we are investigating. So every time we add a particular starting point. Now we are going to switch gear for the next part of the presentation, and we are going to be asking questions about the entire graph. And within the entire graph, we'll try to identify suspicious patterns that we want to investigate. So the actual occurrences of the suspicious patterns will act as entry points for new investigations. So this time, the graph queries will create the opportunities for investigations, whereas in the first section, the graph queries were there to help conduct the investigation itself. So let's start with a first example. So the first of the questions that we are going to be asking is, who among my clients has received more than 10K in the last 3 months? So it's something that I can ask in English fairly easily, not too complex of a question, I guess. But it's interesting in the context of anti-money laundering, because sometimes you have clients that are receiving smaller chunks of money, but that on aggregate can represent something significant. And this breaking down of the transactions, the money that they receive, can help bypass the scrutiny of the financial investigation teams. So we are going to look at the query itself. So it all starts with a match clause. We are looking for bank accounts connected to transactions. And then we have a where clause where we do some first type of analysis. We are checking that the transactions happen within the last 90 days. So we do that. Then we collect the results, and we do the sum of the amount of all the transactions, which then becomes a new variable called total. And then we are just making a quick check, verifying that the total is above the threshold that we defined, which is $10,000. Then we actually return the results. So that's it for the query. Now we are going to see how Linkers Enterprise can help me with running that query and leveraging that query to identify suspicious patterns. And for this, we will be using the alerts dashboard in Linkers Enterprise. So I'm going to go ahead and click on alerts. We see 2 alerts that we have created for the purpose of this demo, and we are going to inspect this one. So I'm going to look at this alert from the perspective of a developer or data scientist, and I'm going to go ahead and click on edit. So there you have it. So this is the graph query that we saw earlier. We do some processing, I guess, to specify that we want to use the name of the bank account in a name column in the alert dashboard that we will see in a couple of seconds, and we want to display the total as an amount column in the dashboard. So we are simply creating and saving that query, and Linkers Enterprise will be responsible for running the query and notifying you of every occurrences of the pattern described in the query. As an AML analyst, I simply log into Linkers Enterprise, open the alerts, and I can see a dashboard with all the results returned by the alert. Maybe I'm interested in this first result. So I'm going to go ahead and click on that. I can inspect it. Have a quick look at the situation, look at the bank account. If I want, I can double click and retrieve the connections. I have a bit of a streamlined interface that can help me make a quick judgment call and potentially either dismiss the alert because it's non-relevant or confirm it. If I have some doubts, if I need more context information, I can open the full Linkers Enterprise UI by clicking on Open in Workspace. Going back to the Linkers Enterprise dashboard, what's really important to understand is that this alerts dashboard really helps streamline the process of monitoring your graph data. You can quickly pivot from having a graph query with a pattern associated with suspicious behaviors to having something that can be leveraged by your AML analysts. So this is first example, I would say, of a global query. And it's time to switch to another example. So the next query revolves around the structure of the financial transactions in the graph. So it's a little bit different. This time we are going to look for situations where an amount of money is moved from one bank account to another by being broken down into smaller transactions between intermediary accounts. So this process is called smurfing, and it's used to obfuscate the relationships between the account sending the money and the one receiving the money. So this question requires inspecting a bunch of transactions and up to multiple levels. Here we are looking at what's happening 10 level deep. It's something that would be almost impossible to do with a traditional database. So the query that we are going to be using here is inspired by an article from Vlad Batushkov called "Find Circular Money Flow with Neo4j." So I just wanted to give him a bit of a shout out. So let's look into the query itself. So what do we have here? So it starts with a match clause where we are trying to find two transactions, transaction A and transaction B. And we are first doing some first check in a where clause, where we want to make sure that the amount at the end of the cycle is above 70% of the amount at the beginning of the cycle of the cycle, and we want the time. We want to have a time limit between the beginning of the cycle and the end of the cycle, which is at 90 days. So, we are just making some checks between regarding the beginning and the end of the cycle. And then we have another where clause where this time we are comparing the dates of all of the transactions within the cycle, and we want to make sure that they are successive. Okay, and then we simply return the actual result. So that's the query that we can use to identify this pattern. So it's a little bit more complex, I guess, than the queries that we worked with previously. We are going to see now in Linker Enterprise how we can make sense of the results. So we have one such result. We have a starting node, and we see how money is flowing through a bunch of accounts until it reaches last step with this make account, and we can inspect the individual transactions if we want to, or we can look for a given bank account. We can look at everything it's connected to, such as, for example, via Ascent, as bank account relationship, or whatever. Maybe I want to identify the person owning that bank account. I can do that. It's fairly easy to do so. So Linker Enterprise helps me not only detect the actual occurrences of the pattern, but also inspect the results. Okay, going back to the dashboard, going back to the presentation now. And we are going to look at one last example. And for this last example, we are going to be relying on Neo4j's Graph Data Science Library. I don't know if you have already used it or heard of it, but it's quite powerful, and we will be seeing right now how it can be leveraged in the context of anti-money laundering. So for this example, we are going to follow multiple steps. We will look into groups of clients sharing personal information, such as phone numbers, addresses, emails, addresses, etc. So this can be indicative of fake identities with money launderers creating fake clients in order to hide their real identities and escape prosecution. So we are going to follow a three-step process. At first, we are going to create a projection, a graph projection. then we will detect within the projection the weakly connected components via graph data science algorithm, and then we will inspect these, the bigger components, I guess. So here is the query that helps us create the graph projection. So it starts with a match clause, where we are, basically focusing on the persons, and then we create a subgraph based on the relationship between person across these different types of relationships. Okay. And then we are leveraging the newly created graph projection titled individual graph, and we are running the weakly connected components on that subgraph. And we are adding some new properties to the nodes. Specifically, we are adding a component ID property. So it's going to be something that we'll be able to use later to leverage the result of the algorithm. And now we are going to see in Linkers Enterprise how we can actually leverage those results. Once again, we will be using the alert dashboard, except this time we will look into the fake identities alerts, and we are going to be inspecting the groups based on the component ID that are the bigger ones. Double clicking on the alert, I can see that we have a bunch of results this time. We can arrange them by score, for example. And we can, inspect individual results. Okay, so I'm looking at that particular result, for example, and we see that we have 1, 2, 3, 4, and even 5 clients, and they're interconnected across an IP address, another one, a third one, or even if I zoom in here, an address. So Linkers Enterprise, really helps me leverage the power of the graph data science library in the context of AML by making the query accessible to non-technical users with an interface which is designed for investigation of suspicious patterns. I'm going back to the Linkers Enterprise UI, going back to my presentation. I just wanted to have a quick word regarding how it works and give you a bit of an overview of how to leverage Linkers Enterprise to accomplish the same type of work on your own. So there will be 4 steps to that process. The first step will be for you and your team to define the relevant data for your project. Then you, as a graph expert, or someone from your organization, or someone from Linkerius, or one of our partners, will import the data into a graph database. Then the end users, the analysts, would work with the graph expert to customize the look of Linkers Enterprise and implement analytics based on your requirements. And finally, the analyst would use Linkers Enterprise to investigate the criminal networks, and they can do that either in a standard mode via the full Linkers Enterprise UI that we just experienced together, or within one of your existing apps via the Linkers Enterprise API that facilitates that type of integration. So that's it for today's presentation. I really hope that it has helped you understand how to use Linkers Enterprise and Neo4j in the context of anti-money laundering. And what I want to emphasize is how, by combining these 2 solutions, you can accelerate AML investigations and identify AML schemes that would otherwise go undetected. If you want to know more, you can visit linkerio.us or drop us an email at contact@linkerio.us. And of course, if you have any questions, I would love to hear them. Thanks.